Hey guys, welcome to the start of chapter 7. I say this a lot, but this is one of my favorites. It's actually really fun, really good, really helpful in real life actually. There's more application problems we can do in this chapter, which is exciting. So yeah, this is similar to when we learned about graphing equations in slope-intercept form, where we talked about actually graphing in probably 3 or 4 different ways before I finally taught you a slope-intercept form. For this chapter, I'm going to teach you 3 different ways to actually solve linear systems, and then you get to go it on your own here. So I'm getting ahead of myself. Remember that these are just the highlights from a lesson, little refresher for kids who have been gone. Not the best lesson in the world, not perfect. Other math teachers may and probably will do it a little bit different. That's totally fine. It's just for our little purposes here. Okay, so before we can solve a system of equations, we need to know what that is, right? Okay, so here's an example of a system of linear equations, right here. So this is 2 or more equations where we are only going to find one coordinate that satisfies both of them. So up to this point, you have had to tell me, oh, for example, does point -2, 10, does that satisfy this equation? Or you could say, is -2, 10 on this line if I were to graph it? And you sub in -2 for the x and 10 for the y, and you're like, oh, doesn't balance out. Well, this is similar in that we're going to do one coordinate and it has to satisfy both. And we'll talk later about what that means. Okay? Now, actually, the solution for this system is 2, -3. Now, later in the lesson, of course, you're going to find that, but I want to kind of teach this to you backwards so that you can kind of see what we're doing here. So 2 is in the x position, and y is -3. So that means, sorry, there's a train going by. I can put 2 in for x, 2 in for x, -3 in for y. Everything else comes down the same. -2. Let's see. -3 for y, 2 for x. Right? The only thing that changed is I subbed in the number for the variable. All right, -2 times 2 is -4. -4 plus 1, yeah, that's -3. Great. Well, that balances. So now I know that this point is on this line. Let's try the other one. -2 minus 5 is -3. Yeah, -3 is 3. So that means this point is on both of these lines. Let's see how we're going to solve that by graphing in a bit. But again, this is a preview of all the different methods that we will be using in this chapter, just so you know ahead of time that there are multiple methods. Okay, so let's see what happens, since this is about graphing, if I were to graph both of these equations. So here, this whole front page is one whole problem. Here's the top equation. And it's written here again too. Okay. All right. Looks like it's in slope-intercept form, and I can graph. I don't have a straight edge. Hang on. Okay. I don't have a straight edge, but I have a tomato. So my intercept is 1, and slope is at -2, which can either be up to left 1, or it can be down to right 1. So I'm going to graph that guy. Told you I have a tomato. It's kind of hard to use it as a straight edge. Okay. And then we'll do the same for the other equation. This one is the same as this one. Great. So here's the -5 and a slope of 1, so up 1, right 1. Look at that. There was a collision on our coordinate plane. Okay. So let's see if there's anything significant about this collision. Well, what point is it at? 2 to the right and 3 down. But wait. That's what we said the answer was before. Oh, if this point is on this equation and it's on this equation, that's where the 2 lines cross. And can a line cross in more than one place? Can 2 lines cross in more than one place? No. So there's only one solution. This is amazing. One might say it'll blow your mind. It's amazing. Okay. All right, this is just ridiculous. I have 2 trains going by the house. I don't know if you can hear me at all. I'm trying to like shout into the microphone. Okay. So here's the process for this 4-step process. And it's really logical because you've been doing this for a really long time. You'll first write both equations in slope-intercept form, which makes sense because you can't graph something that's not in slope-intercept form. Then you're going to be very careful when you graph your equations. And I like to do multiple points anyway, just so I'm accurate. But when you're solving by graphing, this is extra important that you use multiple points. Find your intersection points. This is like your solution. And then check your solution by substituting in that coordinate for the x and y to make sure it balances, because mistakes can easily happen. It's a lot of work to do. And then find out you have an incorrect solution. Okay? Now, this is not the most precise strategy, so we're not going to use this to do any sort of like landing spaceships on Mars or measuring medication for, I don't know, babies or the elderly. We're going to learn the more precise ones in the next couple lessons. But I do think that graphing is very important because it gives you a visual of what you're actually doing. All right, I'm going to try to zoom out as much as I can so we can see the whole problem at once. Okay, I would like for you to try to do as much of this as you can without me. Now, I know you've only seen it once, might be kind of difficult, but that independent thinking is good for you. And then, of course, you can start up the video again. I'll talk you through it, but see what you can do. Okay, did you see what you could do? Okay. All right, so this top equation, step 1. Is it in slope-intercept form? Yes, awesome. Okay. Now I'm going to graph it using multiple points. The intercept is at -2. Slope is 1. Boop, 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 boop. You can do sound effects too if you want. All right. And make a line with your tomato. If you have one. Can be jealous of my tomato. Okay. And then go on to the next. Is this in slope-intercept form? Yes, nice. That doesn't happen very often. Intercept is at 4. Negative x slope. Boop, boop. What? I think we have an intersection. Of course, we're going to draw our line and we're going to check our work and all those things. We don't just, go with it straight away. Ugh. This is not the best straight edge. Cool. All right. So let's find our intersection point. 1, 2, 3 to the right and 1 up. So the intersection occurs at 3, 1. So let's try it out. 3 should be x and 1 should be y. 3 should be x, 1 should be y. 3 minus 2 is 1. Yeah. 3 should be x, 1 should be y. -3 plus 4, yeah, that's 1. Good job. Star for you. Awesome. Okay. So I think you paused last time to do as much as you could. Maybe you got really far, maybe you didn't get far at all. Do it again. Pause this. Do as much as you can on your own. And hit play again. Okay, did you do it? Did you discover that this one's a little bit more difficult than the other? Yes. To rewrite equations? What? All right, here I have x into y. It's -6. That's not in slope-intercept form. Let's move our x first. Boo. It's just more math you get to do. And y isn't even by itself. Wow. Here we go. Y is -1/2 of an x. Negative over a positive is a -6/2 is 3. Wow, I hope we did that right. 3 down for our intersection, and a -1/2 for our slope. So up 1 left 2, or down 1 right 2. Cool. All right, and then boom. And now we do the other one. It is also not in slope-intercept form. Man. So y equals, variables come first. All right. -10. Slope is 3, so 3/1. 2, 3, 1. 1, 2, 3. Ooh. Looks like we have potential. Boop. Boop. Okay. And connect the dots. No. Alrighty. Let's check it. Do. We have 2 to the right and 4 down. Okay. That means we should sub in 2 for x, -4 for y. Okay, so there's 2. What's 2 times -4? -8. 2 minus 8 is -6. Good job there. Let's try the other one. -3 times 2 is -6 plus -4. Yeah, that's -10. Hey, it works. So this is our solution. Great job. Cool. I made this note here. Check your work in the original equation. So these rather than these. So it improves accuracy. Well, let's look at the practice you get to do. Yay! Okay. This top section is potentially confusing. So let me please try to explain. I'm going to zoom in because these are tiny. Okay. So for these top 6 questions, they are actually 2 separate questions, okay? So for the first time through, just pretend that the other coordinate isn't even there, okay? So this question is asking, is point 1, 1 the intersection of these 2 lines? Or you could say, does 1, 1 satisfy both equations? So put in 1 for x, 1 for y. It doesn't matter if it satisfies one and not the other, it has to be both of them. If it satisfies one and not the other, it means that it's on one line and not the other, and it's certainly not where the 2 cross. Okay? So you're going to tell me yes or no there. Let's just try this one. X, y, 2 times 1 is 2, plus 1 is 3. Well, it works for that one. 1 minus 2 is... Okay, so this first one is a yes. Okay. Now we're going to pretend that we didn't do anything at all. Like we're starting from scratch, right? And so now you will repeat the same exact thing for that second point. And then you'll have a yes or no here. Now I'll give you a hint. Can 2 lines have more than one intersection? So you should not have a yes, yes. Just a little hint for you. Okay, for this next section, you'll use this graph to solve the linear system. So this has already been done for you. So like this is this one, and this, is this one, and your job is to find the intersection, which is the solution, right? So 0 what? You tell me. Blech. I started to write the answer. Okay, you can do 8 and 9. Okay. And then for the next section, you are to graph. The top 3 are already in slope-intercept form. Bottom 3 are not, but I'm sure you can figure that out. Remember, this is a long time ago, but remember an x equals equation goes vertical and a y equals equation goes horizontal. There's a few of those that you're going to be up against. Okay. We are going to do this one problem in class because they are so important for this chapter. I want to be a little bit greedy and make sure that I can help you with this in class, not just on the lesson. So if you miss this lesson, please come see me so I can help you. Speaking of seeing me for help, if you're at home and you're trying to get your homework done, please send me an email if you get stuck. There you go. And hopefully I can get you unstuck. Otherwise, I can hopefully unstuck you when I see you back in class. Thanks, guys. See you later. Bye.